Okay, we have something interesting here today. What I wanted to do is just derive our series definition for the digamma function, starting with the Weierstrass product definition for the gamma function. Now, before I do anything, I think maybe let's clean up this little bit right here. I feel like writing this a different way. If I get a common denominator on this, this becomes k plus z over just k, just creating a k over k term for this one right here. And if this is all to the minus 1, I can just flip it and write this as k over k plus z. And then what I want to do to simplify it, it's kind of like some of the other derivations we did. Let's just take natural log on both sides. So on the left, this is just going to become natural log gamma of z. And then over on the right, what I'm going to do with log proper is we can start breaking it up because all the multiplication and division can be split up. So like first, just dealing with this, we'll have natural log, I'll leave it and reduce it in a minute. So I'll write it as natural log e minus, that's the Euler-Mascheroni constant there. Then for this, we're dividing, so I'll subtract it. We'll have natural log of z. And then over here, because we have the product symbol, when you take the natural log, if we're multiplying all this stuff, it's kind of like the situation if you have natural log a times b times c times d. This is going to be, you can turn this into a sum and break it up like ln a plus ln b plus ln c plus ln d. So doing the same thing on this, what we'll do is we'll just add this as now we're going to be summing all these terms, breaking up each one like this. And we'll be going from k equals 1 to infinity. So now we'll have the natural log inside the sum of just e ck times this k over k plus c. But now we can do some more simplification on it. This exponent can come out front, and then we're just going to have natural log of e, but that's just 1. So this first piece becomes minus Euler-Mascheroni constant times z minus ln z. So breaking it up, we'll have this as ln e z over k, then plus ln just the k minus ln k plus z. But now one more thing, we'll do the same thing we did here on this one, bring this out front. Again, ln e is 1. So this thing right here is just going to become z over k. And then from here, all I want to do is differentiate on both sides with respect to z. So we'll do it here, and let me kind of squeeze it in here. It's going to be around all this stuff though, differentiating with respect to z. Over here on the left, this is going to be easy. It's going to be 1 over gamma of z, chain rule, derivative of gamma of z. Then over on the right side, one term at a time. So this, we just have a constant on z, so this is just going to be minus Euler-Mascheroni constant. Here, derivative of ln z, we're going to have minus 1 over z on this one. Then we'll differentiate inside the sum. So on this one, it's just going to be 1 over k here. This whole thing is a constant. There's no z, so that one's going away. This one is just going to be minus 1 over k plus z. But then chain rule actually is nothing because then when you differentiate z, you just get a 1. So this is what we have. But now we're getting close because this right here, this is actually our definition for the digamma function. This would be right here, digamma of z. So this left side is going to be digamma of z. We're getting really close, but let me clean up the board and we'll finish it off. Okay, now comparing this to our goal up top here, we're really close actually. There's only a couple differences. The input on this is z plus 1, and over here it's z. So technically that doesn't quite line up where we've got, I mean, in some cases you could do it with an index change, but we're already, this right here is already identical to this. And then we've got this minus 1 over z term hanging out. Now there is a few different ways to do it. One thing you might notice, if you just add this on both sides, on the left side you'll have digamma of z plus 1 over z. Well, this is actually like our reduction formula because this thing is actually equal to digamma of z plus 1. So we could do it that way, but I kind of want to avoid any like possible circular reasoning in this. And so I just, maybe it doesn't matter, but I kind of don't want to depend on that. So instead, I just kind of want to try to merge this back into this sum over here and do it that way. So on this, for 1 over z, I can actually kind of look at this as 0 plus z. Of course, that's not changing it. And then if you look at what's happening here, we don't really have to worry about this term because when we bring this in, it's not going to affect this. It's like, how do we merge this with this piece right here? If we start listing out terms, and just focusing on this, when starting from k equals 1, they're all going to have minus signs, right? So it's going to be like minus 1 over 1 plus c minus 1 over 2 plus c minus 1 over 3 plus c. You get the idea. So this is going on to infinity. Well, if I merge this into our sum, just bring this down, I've just added in this 0 plus c term. So if I bring this thing into the sum, it's kind of like we're changing the index to 0. But of course, I don't want to do that because then because if we change the index, then I'm dividing by 0 right here. So what I can do instead is actually, if I just subtract minus 1 on this right here, get rid of this, and then you start listing out terms, then you notice it works, right? Because you plug in a 1, 1 minus 1, 0 plus c. Then you get, then a 2, 2 minus 1, 1 plus c. 3 minus 1, 2 plus c. So you get all the same terms if you just write it this way as z minus 1. And then from here, all I want to do is I just want to clean up this. I don't really want this minus 1 here. Let's plug into this. If I plug in, let's do this as s plus 1. So we're saying we want to set z equal to s plus 1. Plug it in everywhere. We're going to have minus Euler-Mascheroni constant, this sum. The 1 over k is not affected. Minus 1 over k. Plug in s plus 1 here, minus 1. But then here, 1 minus 1, that's just 0. And so all this stuff I can just write as an s. And then from here, let's just do a variable change. Let's just change this back to z to make it look like what we want. So we have digamma z plus 1 minus Euler-Mascheroni constant plus the sum 1 over k minus 1 over k plus z. And this is going to be our formula, our series definition for digamma of z plus 1. Okay, that's it for today. Thanks everyone for watching. Have a good day.